Okay, we got a couple of errors here. That's just because the agent node is looking for an FBX which is not there. But that's fine. We'll look at that in a moment. What I want to do first of all is use one of the characters here, the mocap biped 3, to set this to T-pose and just look at the very basic setup, the predefined setup they've got on Houdini for ragdolls, right? So I'm just going to put this in a T-pose, leave it in place animation. Doesn't really matter. We're not we don't care too much about the animation for this, right? So I'm just gonna do this as a test to look at the very bare bones of what you need for a ragdoll simulation. Okay, so just create another geometry here, same as before. Set up, grab an agent, FBX, and then just go and find, oops, not FBX, sorry, character rig. Grab that mocap biped, just leave it all at default, and then so the two nodes which set up everything that we need are the agent, configure, joints, and a collision layer. So I'm going to start with the collision layer. Okay, and then in here, the reason I'm doing it with this character is because we've got this preset in here, and there you can see the collision layers pop up, and then I can drop an agent, configure, joints, drop that in, turn that on, and the same here, we've got a preset for this guy, and there you see the cone twist constraints set up. And then if I just drop down a test simulation ragdoll, just connect that up, so there's literally 4 nodes, 4 SOP nodes, and we should have a working simulation. And there we go. Okay, I put that, yeah, it's on real time already. Right, so there you go, we've got the ragdoll simulation working. The reason I showed you that is it's just a good idea to, if you're having problems or you've got weird simulations or weird results from your simulation, it's good to look at this as a reference, okay, just for basic, you know, does my setup look similar to this, right? So the collision layers, we have capsules in this case for each body part. So you go around your rig and choose. You don't need to create a shape for every bone. So for example, here in our rig, I think we've got bones, you know, separate bones for the fingers. You know, that's not necessary. It's up to you how detailed you want to go, and also how much your computer can take. But this is fine, you know, for most simulations. One for the hand, one for the feet, one for the thighs and the lower legs, maybe 1 or 2 for the torso, right? You can use a capsule or a box, as you can see here, or a sphere, this one's stretched out, or custom. You can bring in your own geometry as a collision layer. So we're using these this geometry because that's how Bullet works, right? Bullet needs convex geometry to work well. It can work with concave geometry, but it's generally recommended not to do that. So it works well with these kind of very simple convex shapes. And the idea, just like when working with ABD, with fractures, you generate an approximation of your geometry, simulate that. It will run quickly. You can run iterations and cleanly, and then apply the animation to your geometry. So there we have the object. So without that, if we try and simulate it, I think we'd get something quite weird. You see it all kind of falls apart. So that's what it looks like when, you know, your constraints or your collision geometry is not set up properly. You get this weird stretching going on. Okay, so to hold those together, we build our constraints here, and we can visualize them. If I press W, it's easier to see. So you can see, for each constraint, we're connecting 2 bones, and we've got a kind of cone. They're called cone twist constraints, and they allow the joints to move within this perimeter. Okay, so you've got control over how much it can move around in there, and also you have control over the twist. So this bone can spin around this much within this on this axis, right? So that's perfect for setting up joints, right? Because for something like the elbow, you want it to only be able to rotate on one axis, and maybe not spin around at all. Like here, the hand or the wrist here will have a bit more and be able to spin a little bit as well. Okay, and so you can do it like this. You can also, if you notice here on the configure joints, you have create limits for collision layer. So what this does is takes in, if you have a few animation clips connected, it will use those. You just click on this and it does it all for you. It will use the animation clips to set your constraints for you, basically, which is quite handy. Great. Okay, so obviously we need to set this up by ourselves, and I'm not going to use this setup. I'd like to do it. I prefer to do it myself and have a bit more control. Okay, so we'll do that in the next video.